All right, so today we're diving into um, identification of systematic errors of image classifiers on rare subgroups
Okay.
by Metzen and the rest of the team.
Yeah.
And this is, as data science people, we all know
Right.
that systematic errors are like a thorn in our side.
Absolutely.
It's, when a model, it's doing great overall, but then it
Yeah.
just completely messes up on very specific subsets of data.
Yeah. Yeah.
So like a classic example is you've got this image classifier that's, really good,
Right.
but it keeps mistaking, say, a minivan
Okay.
for a snowplow,
Interesting.
but only in very specific situations.
Yeah.
Like with certain backgrounds or certain lighting.
Mhm.
And that's what makes these systematic errors so
Mhm.
tricky, is that they often lurk
Yeah.
within these rare subgroups of data.
Yeah. They can be really hard to catch with our typical testing procedures.
Exactly. And that's where this paper really shines.
Okay.
Because the authors introduced this new method.
Yeah.
It's called PromptAttack.
Okay.
And it's specifically designed to go after these hidden errors.
That sounds interesting. So how does it work?
Well, the core idea is actually pretty elegant.
Okay.
They're using the power of those text-to-image models,
Right.
like Stable Diffusion,
Yeah. I'm familiar.
to generate synthetic images,
Okay.
specifically for those rare subgroups.
So instead of relying on real-world data for these edge cases,
Yeah.
they're essentially creating their own data.
Exactly. It's pretty clever, right?
It is, yeah.
So they start by defining this thing called an operational design domain,
Okay.
which is basically breaking down a category like, say, car, into all its possible variations,
Right.
like color, background, type of car,
Yeah.
all those things.
Okay.
And then they use this domain to craft very targeted prompts
Right.
that describe these really specific and potentially problematic subgroups.
I see.
So like an example would be a red minivan
Okay.
in a snowy forest.
Interesting. So they're almost writing the image descriptions that would cause the model to make a mistake.
Exactly. That's a
Yeah.
good way to put it.
Okay.
And then these prompts get fed into the text-to-image model,
Right.
which then generates a set of synthetic images
Right.
representing those very specific rare subgroups.
So they then use these synthetic images to test the image classifier.
Yeah.
Okay. That makes sense.
So it allows them to see how the classifier performs on those rare cases and hopefully pinpoint the errors, right?
Exactly. And what's great is that it lets them explore so many more
Yeah.
potential errors than they could with just real-world data.
It's impossible for you.
Yeah, just imagine
Yeah.
trying to collect real-world images for every possible combination of, a car's color and type and
Yeah.
the background and the weather.
And the lighting. I think it would be a nightmare.
Yeah, absolutely.
Yeah.
But generating this synthetic data like this,
Right.
I mean, it must have its own challenges.
Oh, yeah.
How do they make sure that these images are actually good and relevant? That's a great question, and it's something they actually talk about in the paper.
Okay.
They discuss this risk of creating images that are kind of out of subgroup.
Yeah.
Or even out of class.
Lily.
And that could lead to false positives in the results.
Right.
So you can imagine, like, you give it a prompt for a red car, but it accidentally produces an image of a fire truck.
Yeah.
That wouldn't be very helpful.
Not at all.
No.
Right.
So to avoid that, they really emphasize the importance of this careful prompt engineering.
Right. So it's like a balancing act.
It is, yeah.
You need enough variation to test for the weird cases.
Yeah.
But you also need those images to actually represent the subgroup you're targeting.
Exactly. And they actually go on and show how effective PromptAttack is through a series of experiments.
So let's get into those.
Okay.
What specific classifiers did they target?
Okay, so one experiment focused on ImageNet classifiers.
Okay.
And specifically, they were looking at misclassifications of minivans. And they found that PromptAttack could successfully identify prompts that would lead to consistent misclassifications.
Like what kind of misclassification?
Oh, for example, confusing minivans for snowplows.
Oh, wow.
Or pickup trucks.
That's interesting because those are pretty distinct categories.
Yeah.
What could be causing the classifier to make those mistakes?
Well, it probably comes down to the classifier picking up on some subtle features that are shared between those categories, but only in very specific circumstances. Remember, we're talking about these rare combinations of factors.
So it's like in those specific images, something about the shape of the minivan, or its position, or like the stuff around it.
Exactly, maybe the background.
Was throwing off the classifier.
Yeah.
And PromptAttack was able to create those exact scenarios.
Exactly like cracking a code.
Yeah.
The error only happens when all the pieces are in the right place.
It makes you think, like, how many of these vulnerabilities
are just hiding in our models, waiting to be triggered.
It's a scary thought.
It is, yeah.
Yeah, and it really underscores why we need tools like this to help us find them.
Absolutely. So they showed that PromptAttack can find these multi-factor errors.
Right.
What else did they do to prove that their approach works?
Okay, well, they introduced this really interesting thing.
Okay.
It's a zero-shot systematic error benchmark.
Okay.
And they use this to actually evaluate how accurate PromptAttack is.
So how does that work?
They use these pre-trained models, like CLIP, to create these controlled scenarios where they intentionally put in errors.
Oh, so they were like setting traps for PromptAttack.
Right, exactly, to see if it could find them.
Okay. And did it work?
It did, yeah.
Yeah.
They ran it against a bunch of different image classifiers.
Yeah.
And it was able to successfully identify the prompts that led to those errors.
Wow.
So that really showed that it can accurately detect
these
systematic errors.
That's impressive.
Yeah. It sounds like PromptAttack could be a really valuable tool for building AI systems that are more reliable and robust.
Absolutely. And especially in areas where those errors could have serious consequences in the real world.
Right. I'm already thinking about how this could apply to like my current project, which
it
really makes you think about like how complex this whole thing is.
Yeah.
Like all these potential subgroups and all the different factors that can contribute to these misclassifications.
That's like this hidden web of vulnerabilities.
Yeah.
And we're just starting to understand it. That's why tools like PromptAttack are so important.
Yeah.
They give us a way to actually systematically probe for these things.
Absolutely.
Yeah.
So it's not just about finding the errors, though, right?
Right.
It's about understanding why they happen.
Exactly.
And then what we can do to prevent them in the future.
Yeah. Did they talk about any, like, specific strategies?
Yeah, so they do mention data augmentation as a potential way to address these errors.
So the idea is that if you add more diverse examples to your training data, especially those representing those rare subgroups, you can improve the model's robustness.
Okay, so it's like by exposing the model to more variations, you're giving it like a broader perspective.
Exactly.
So it's less likely to be caught off guard by something it's never seen before.
And less likely to rely on those spurious correlations.
That's a good point. And speaking of spurious correlations, one of the things that really struck me about this paper was how it highlighted this potential for bias.
Yeah.
Like, even if we're not intentionally feeding in biased data, the way the models learn can inadvertently lead to biased outcomes.
Especially if there are biases already present in the data.
And those biases can then show up as systematic errors.
Exactly, like where the model consistently performs worse on certain demographic groups.
Exactly. And it's tough because these biases can be so subtle. It's really hard to detect them without a tool like PromptAttack.
Absolutely.
To help us probe for those vulnerabilities.
It really highlights this need for a more holistic approach to AI development.
So it's not just about optimizing for accuracy.
Right.
It's also about considering the ethical implications.
Exactly. We need to be mindful of the potential for these models to amplify existing societal biases.
And then develop strategies to mitigate those risks.
PromptAttack can be a really valuable tool for that.
Like shining a light into those dark corners.
Yeah.
Revealing the biases that we might not even know are there.
And that awareness is the first step to fixing the problem.
It challenges that assumption that we can just train a model on a huge data set.
Right.
And magically get fair and unbiased results.
We need to be more proactive and intentional about building ethical and equitable AI systems.
And tools like PromptAttack give us the power to do that.
Exactly.
They let us ask those tough questions.
Yeah.
Scrutinize our models for potential biases. And really hold ourselves accountable for the results.
It's a shift in perspective.
They're not just building models that work.
Right.
We're building models that we can trust.
And that trust is built on transparency, accountability, and a commitment to fairness.
Well said. Now let's talk about some of the limitations of this approach.
Sure.
The authors do acknowledge that there's a potential for false positives because of the limitations of the text-to-image models that are used to generate the synthetic images.
As impressive as these text-to-image models are, they're not perfect.
Of course.
There's always a chance that they'll create an image that doesn't accurately represent the subgroup.
And that could mess up the results of PromptAttack.
Exactly. So it's not foolproof.
Right.
We still need to use human judgment and interpretation.
So the authors recommend careful prompt engineering.
Yeah.
And robust statistical analysis to try to minimize those false positives.
But it's important to be aware of those limitations.
Yeah.
And to use PromptAttack as one tool among many.
I think the key takeaway here is that while PromptAttack is a great new approach, it's not a silver bullet.
Exactly.
We still need to be thoughtful and critical.
It's about using a combination of techniques.
Yeah.
Both quantitative and qualitative.
To get a full understanding of our models.
And to make sure they align with our ethical principles.
That makes sense now beyond the technical stuff.
Yeah.
I'm curious what you think about the broader implications of this research.
Well, I think this research highlights this growing trend in AI.
Okay.
Which is a move away from purely data-driven approaches.
So instead of just throwing more data at the problem, we're starting to think more critically about the data we use.
Exactly.
And the models we build and the potential consequences.
We're recognizing that AI is not just a neutral technology.
It reflects our values, our biases.
And as we develop more powerful AI systems, we have to make sure they're aligned with our human values.
It's like we're moving from a technical domain to a socio-technical one.
Exactly.
Where ethics and fairness and societal impact are just as important as performance.
And that requires a new set of skills and perspectives.
We need AI developers who are not only technically good, but also ethically aware and socially responsible.
It's not enough to build a model that just works.
Right.
We need to build models that we can trust.
Models that are fair, transparent, and accountable.
Yeah, and that requires a fundamental shift
in how we think about what it means to be a successful AI developer.
And I think this research is a sign of that shift happening.
Yeah.
Tools like PromptAttack are giving us the ability to really interrogate our models in new ways.
To expose the biases.
And to hold ourselves accountable.
So we're empowered to build AI systems that are not only intelligent, but also ethical.
It's a future where AI isn't something to be afraid of,
but something to embrace.
As a powerful tool for good.
Now, before we move on, I wanted to go back to something you mentioned earlier about the operational design domain being a key part of PromptAttack.
It's important because it forces us to think systematically about the potential failure points of our models.
So by defining all the variations within a category, we're essentially anticipating those edge cases.
And building more robust models right from the start.
Instead of waiting for those errors to show up in the real world.
Exactly. It's proactive risk mitigation.
Which is essential when we're talking about AI systems that we have to rely on.
Especially in high-stakes situations.
It also reminds us that the quality of our models is only as good as the data we train them on.
If our data is bad, our models will be bad.
So this idea of the operational design domain, it really makes us think critically about the data.
How we collect it, how we label it, how we use it to train our models.
It's about being intentional and thoughtful.
At every step of the process.
Exactly. And remembering that AI is not just a technical endeavor. It's a human one.
And it needs to be guided by human values.
It's amazing how advancements in, like, text-to-image generation can have such a big impact on model evaluation. It makes you wonder what other unexpected connections we might find as these different areas of AI keep evolving.
I think we're just scratching the surface of what these generative models can do.
And as they get more powerful and easier to use, it'll be interesting to see how that changes AI research.
Do you think we'll see more researchers using these techniques?
Oh, I think it's inevitable.
Yeah.
As the tools become more accessible,
right,
we'll see more people experimenting with them.
Yeah, both in academia and industry.
Exactly. And that can only lead to faster progress and more innovation.
Absolutely.
It's really an exciting time to be working in this field.
It is.
But like you said before,
yeah,
we need to approach these advancements responsibly.
Right.
As we develop more powerful AI systems.
Yeah.
We have to be aware of the potential risks and biases.
We can't just assume that these models will be fair and unbiased. We have to be proactive in identifying and mitigating those risks.
Tools like PromptAttack can help us do that.
They can, but it's up to us to use them responsibly.
It's a good reminder that even though the technical side of AI is fascinating, we can't forget about the human element.
Right. These systems are built by humans, used in human contexts.
And ultimately impact human lives.
Exactly. So we need to make sure that our values are reflected in these systems.
Well said. This paper has given us a lot to think about.
It has.
From the details of PromptAttack to the bigger picture of systematic errors and the importance of ethical AI development.
So for our listeners out there working on image classification models, what are the key things they should remember?
Well, first off, even the best models can have these hidden vulnerabilities.
Right, especially on those rare subgroups of data.
So don't just look at overall accuracy.
Go deeper. Look at how your model performs on specific subgroups.
And that's where PromptAttack comes in.
Yeah, it gives you a way to test your models.
Yeah.
Find those weak points and really understand how your model might behave in the real world.
It's about thinking beyond the lab.
And considering how your model will do out in the wild.
Where it'll encounter all sorts of unexpected things.
Exactly. And once you've found those potential problems, be proactive about fixing them.
Think about data augmentation, different model architectures.
Fine-tune your training process.
To make your model more robust.
It's a continuous process of improvement.
Always questioning our assumptions and challenging the way things are done.
And remember, it's not just about technical performance.
Right.
It's about building systems we can trust.
Systems that are fair, transparent, and accountable.
So as you build your models, keep those ethical considerations in mind.
Yeah.
Think about the impact of your work.
Both the good and the bad.
And try to build systems that benefit everyone.
Those are great words to end on.
Yeah.
Thanks for joining me for this deep dive.
My pleasure.
Into the world of systematic errors and how we can tackle them.
And to our listeners, keep exploring, keep innovating.
Yeah.
And keep pushing the boundaries of AI, but do it responsibly and ethically.
Until next time.
Yeah.
Keep learning and stay curious.